This is ACT Science, Passage 6. This is a research passage. We know it's research because we see Study 1 and Study 2. Our DRC approach, research means read, not carefully, but you want to look at the process and the differences between the two studies before going to the questions. Probably somewhere between 30 seconds and a minute before you get to the questions. That's what works for most students. We're going to use the R&R approach to understanding the questions. Read the question first, then reread and break it down step by step. That's what we're going to do together. Question 34, based on the results of the studies, the absolute value difference between theta S and theta C. I think that S stands for slide and C stands for critical value. It doesn't matter. We're just going to call it S and C. Was greatest for which of the following pairs of trials. So we're going to process of eliminate. So we have theta S, theta C. We're going to look first at trials 1 and 7. So we have 43 minus 22. Absolute value, doesn't matter which one you put first, right? So it's going to be a positive no matter what. So it's 21. Trial 2, 31 minus 14 is 17. Trials 3 and 9 is going to be 11 minus 3. And trials 4 and 10 will be 37 minus 30. So the greatest value is 21, choice F. 35, based on the results of study 2, as K increased, theta C did what? So again, this K, I think, stands for kinetic energy, stands for the angle of the critical value when it starts to slide. Doesn't matter, just call it K and C. So as K increased, what does C do? This one's a tricky one because they're not in order. See, it goes from 40 to 25 to 05. So we have to put them back in order or check point by point. I like to put them back in order. So we have reordering them, start with 0.05 to 0.19. There's 2.25s that have the same values. So you only have to count them once. 0.4 and then 0.58. So as K gets bigger, C gets bigger as well, increased only. 36, based on the results of the two studies, so studies 1 and 2, for each combination of plane and block tested, compared to the coefficient of kinetic friction, so that's this one, the coefficient of static friction was what? So kinetic friction, static friction. So we're going to just check each one, right? So glass to glass, the static friction was greater. Same thing, glass to metal, glass to wood, metal to metal, metal to wood, and wood to wood. It's always greater for the static friction. So the answer is F. Number 37, can it be determined from the results of the studies whether the value of theta S for a given block depended on the mass of the block? So that's when it slides, right? So if we look at study 1, we see theta S, but mass isn't listed anywhere in there. And in study 1 description, it says 3 blocks, all 1 kilogram each. So they're not testing any different sizes. So just knowing that, we could eliminate choice A and choice B. And then it's a little bit of logic, and you have to say, no, they all had the same mass. So choice D is the correct answer. Number 38, in study 2, the students performed the minimum number of trials necessary to test each substance with itself and every other substance listed in table 2. Suppose they had listed a fourth plane. So this means you got to think. And a fourth block in study 2, each made of concrete, so it just gives you a different material. What's the minimum number of trials that would be required to be tested for each of the 4 substances? So we can use the existing data to help us understand. So if we just do a chart, right? Glass, metal, wood, and glass on glass, glass on metal, glass on wood is 3 trials. Now, we're not going to test metal on glass because we already tested metal and glass, right? I realize one is the block and one is the plane, but that's not what we're worried about. We're worried about the substances creating friction with each other. based on the data that the students did. So then they test metal on metal, metal on wood. Again, we're not going to test metal on glass and wood on metal because we've already tested those. And then wood on wood. That's 6 trials. If we add concrete, we're going to have to test them all again. You can see how this pattern sort of works, right? So we have 7, 8, 9, 10. The answer is G. In study 1, why, suppose if why, you're going to have to think, did the block in a given trial begin to move? So study 1 is where they raised the platform and tested when did the block start sliding. So what's the force that makes this slide? Well, that's a knowledge question to some degree. The force of gravity is what causes the block to move once enough friction is reduced. That's what they're testing. When is the friction not enough to hold it in place? So choice C tells us that the frictional force was decreased, so the gravitational force could accelerate. It would be tempting maybe to choose choice B. The gravitational force was increased, so the frictional force could accelerate the block. But this frictional force does not accelerate it. It prohibits it from moving. That's why B is wrong. So your answer has to be C. Number 40, in each trial of study 2, theta was initially 45 degrees. So that tells us there that they started at 45 degrees. Based on the results of study 1, which of the following statements best explains why the initial value of theta was chosen? So what they're doing in study 2 was they had a ramp and they're raising it, or it's already raised, to see at what angle when they lower it does it stop moving. So it had to be greater than S, and we can see that here, right? So that whenever they put the block on there, it would start sliding. So your answer has to be J. We could eliminate for sure, even if you didn't rationalize your way into that answer. You can eliminate F because you know they're not equal. And you know it's not less than C. So the initial value would have been greater than S. Here's our answers to our questions. F, A, F, D, G, C, J. We don't have any evaluations of models in this particular passage. Reach out if you have any questions, and we'll end with our silly joke. I just finished a book all about sandpaper. It's the best friction book I've ever read. Have a good day.